In this video, we're going to talk about literal equations. And essentially, literal equations are basically those that involve two or more variables. So one that we're really used to seeing is slope-intercept form. So if we have y equals 2x plus 7, the equation contains both the variable y as well as the variable x. And we can see in that case when it would be useful to rearrange or solve for a specific variable. So in that case, we typically solve for y so that our equation will be in slope-intercept form. And so we're going to look at some other formulas as well, just some equations that it is helpful to solve for a specific variable. So here's our first equation, and again this would be an equation where it would be helpful if we were trying to graph this to solve for y. So we're going to solve for y. First thing we're going to do is add 12x to both sides. Remember that these two are not like terms, so I can't actually add them together. I can just write them next to each other as 12x and then plus 18. Next I want to isolate y. So I'm going to divide every term by 6. Since these are being multiplied, in order to undo that, I'm going to use its inverse operation, which is division. Dividing by 6, I get y equals 2x plus 3. So again, if I was given this equation, it would be helpful to solve for y, to put it in slope-intercept form, so that I could solve for, so that I could graph it easily. Here's another example. Again, we're going to solve for y. So I'm going to subtract 15x. I end up with negative 5y equals, again, not like terms, so I can't actually combine them. And then I'm going to divide everything this time by negative 5. Negative 15 and negative 5 becomes 3x minus 5. Sorry about that. 3x minus 5. Alright, in this case they want us to solve for x, so we're going to get x by itself. So this time I'm going to subtract 4y. And I've got 3x equals negative 4y plus 16, and the order really doesn't matter on these. Divide everything by 3. So I've got x. Sorry. Alright, try this again. X equals negative 4/3 y plus 16 over 3. You could change this into a mixed number and make that 5 1/3, but please don't turn that into a decimal by dividing, because it's not going to be a terminating decimal, it's going to be a repeating decimal. So we'll leave it like that. You could also write this, now that I'm looking at it, negative 4y plus 16 all over 3 if you wanted to. Either way is fine. Alright, formula for finding the area of a triangle is 1/2 base times height. So it tells us, suppose that we know the area and the height, but we need to find the length of the base. In this case, it would be helpful to solve for b. So that's what we're going to do. We're going to take our formula and we're going to solve for b. So my formula is area is equal to 1/2 base times height. Alright, and we're going to solve for b. So the first thing I'm going to do is get rid of this fraction. If it's 1/2, I can do that by multiplying both sides of my equation by 2. And that's going to get rid of my 1/2. So now I've got 2a equals b times h. And again, I'm trying to get b by itself, so I'm going to divide by h to get rid of the h and get the b isolated. So my answer is 2a over h. So same idea, still following that same process, except now we just had an extra variable in there. Last example, the distance that a train can travel. We've got our formula for distance, which is rate times time. We're going to solve this formula for t. So I've got distance equals rate times time. And my rate and my time are being multiplied together. So if I want to undo my multiplication, I would have to do the opposite, which is divide. So getting t by itself, I'm going to divide both sides by r. And I'm going to have time is equal to my distance divided by my rate. Alright.